Alright, hello everyone, welcome. I'm gonna try to set up my computer. I realized today that sadly, or it was actually yesterday evening that I realized that my computer actually is cracked. Like the screen is cracked. So I'm not sure if I can pull up the Discord. I decided not to do it yesterday since I thought it wouldn't work, but let me at least try. But hopefully everyone has had or is doing well. I'm doing a bit of an earlier stream since I decided. I mean, I only have seminars today, so I decided to skip them, and the questions weren't that difficult. So instead, decided to do a long study stream to hopefully catch up with the courses. And yeah, by the way, this will be I said a study stream, but this will be a math stream, by the way. So yeah, let me see. There you go, like that. Hello, Tora. Have my physics midterm tomorrow. Last midterm. Alright, good luck, Tora, with your midterm. Wish you the best. But I am fairly hungry. Like, I haven't had lunch, so I'll probably do 1 hour or something, and then I'll grab some lunch, and then proceed from there. Taking breaks or not? Yeah, I'll be taking breaks, and I'll just basically leave for 30 minutes during lunch and dinner break. So that's basically the plan. Still charging? Oh. Honestly, this computer is starting to be very scuffed. Okay, well, maybe not. Maybe it won't work. Oh, it wasn't plugged in. Okay. Well, that helps to actually plug in the charger. By the way, I did work on the problem I was stuck yesterday on at the end of the stream. And I did do some... Also, I realized when rewatching a little bit of yesterday's stream that it's better to have my webcam up here, since the channel logo is also in the bottom right, so it becomes kind of difficult to see. At least that's what I gathered from watching yesterday. But yeah, okay, we can turn this on now. Cool. So yeah, basically, I was very confused writing this, taking the exponent of the matrix, and I was still confused when I did it directly after or before starting the stream. But I guess you just have to have... In Sweden you say man måste ha tungan rätt i mun, which basically directly translates to you have to have your tongue correctly placed in your mouth or something. But I guess finding the the exponent in the indices was, I don't know, kind of difficult, but this should be correct now. And I guess one can prove this formula by induction, and that would be fine. And then one could go to just apply it here, and then you would see the Taylor expansions of the sine and cosine. I had some help yesterday, so thanks for the. I forgot exactly who helped, but yeah. There was a lot of support, like mathematical support last stream, which was very nice. I need all the support I can get. But yeah, look at this crack. I'm very, very saddened. Unfortunate. Literally how it was in my bag, and then when I took it out of my bag, it had the crack, and I have no idea how it got there. I have no idea how it got there. Crap, I'm actually really hungry. I should grab something to eat. Combat loneliness when studying. All my other friends are chilling while I'm studying. I mean, you gotta have a balance, and it's certainly like it's something that I combated as well, especially during my high school days where I studied all day. So like go to class, go to lectures, and then maybe study with your friends a little bit, talk about the material, if you have friends that are, you know, want to talk about that. So it's a great way to also study, but also socialize as well. Did you like keep your bed in the cramped space? Oh, I'm not actually sure. I'm not sure what happened. I honestly have no clue. Maybe something got stuck between when I folded my computer. Maybe something got stuck like in between and poked it, like poked the screen. But that's my hypothesis. I actually don't even know what to cook. I mean, I have some asparagus. I'll probably just fry some asparagus with broccoli. So I guess I need to cook as well. Blah, 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 blah. Bro, honestly, asparagus is probably my favorite vegetable. Asparagus is really good. Bruh. I hate my laptop sometimes. Why doesn't it want to work sometimes? Wait, is the touch not active? Brother. Ay, ay, ay. Apparently my touch doesn't work. This lamp has no chill. Okay. Okay, maybe this is not gonna work. I mean, it was anticipated. The touch is completely broken. What's up, Baloo's red hair? How are you doing? Okay, let's change the agenda. I want to start off with doing the ODE stuff. I didn't complete the homework yesterday. So let's do that, and then I'll do some statistics. I have a lot of that to do, and then I'll catch up with linear analysis, or I'll just say Fourier analysis. It's easier to understand. Analysis, and that's basically the agenda for today. Yabba-dabba-doo. I feel you should grab lunch first. So you only study math at uni, right? I mean, I study math at uni, but also I do these streams, of course, which I count as studying. Yeah. Also, when I have lunch every Friday with 2 friends, math friends, and yeah, it's interesting talking about math with them. Name is Paul. Right. I forgot that. Okay, I guess we'll just start. Hello, Bavia. Welcome. But yeah, we get our expansion here, and actually, now that I think about it, I could probably do this a lot better. I can write this maybe better. I need to have 2 cases though. I mean, now that I'm doing statistics, it could be written like with an indicator function. Actually, no. I think it's fine. Yeah, we get I minus IT like this, plus I T3 factorial minus dot plus TB this. So we get TB minus wait, there should be a minus here. Minus T3 3 factorial B no wait, no. Wait, so we have our even terms when this is 0, and then we have, yeah, so it should be even. Yeah, so this should be a 4. And then this should be a 5 here. And this can be written as I times cosine of t plus b times sine of t, which is equal to cos of t negative sine of t. Does that make sense? Moving on. So we need to use this to compute ETA in at most 3 rows on the paper. That's weird. In at most 3 rows on the paper. Okay. So we have a is equal to 2, 1, negative 1, 2. Okay. So this could be written as 2 identity plus b. So we need to compute TA 2i plus b, which is equal to alright, equal to, I mean, by the exponent rules, which we haven't proved. We didn't do that yesterday. I should probably do it. And I should look at other theorems. Anyways, EI right, so we have 2EI times ET. I think we can do it. Let me just check. Yeah. I mean, it should work. And then we have, so this one is 2 times, or E2 times EE. I'm pretty sure. Then we have times t there, so it's plus t. And I guess we could factor out the e as well, so it would be a 3 here. Then we have a 1 plus EB, which we know is equal to the cosine stuff. Cosine of t, sine of t. All that. Let me check restrictions. Let me check so I'm live on the correct things. Okay, cool. Hello AK. Welcome. Alright, so this will be the final answer. I mean, I guess sadly I can't really, I am skipping the seminar, so I can't see if this is correct. But I think I did ask ChatGPT here, and oh yeah, of course, yeah. So this would be T here as well. So I'll just use ChatGPT as an aid. Wait, he's doing I do that wrong? I don't think so. Oh, it would be, yeah, true. It would be e to the 0. I see. Yeah, I did that wrong. That would be e to the 2I is equal to 2 identity. Or no, it's equal to E2 times identity, so it's just E2. That's identity. Yeah. So in that case, we would have let's do this explicitly. Let's do this. You would have 2 KIK, and then you would get this 2K, and this would be e to the 0. Factor out the K. So no. Am I crazy? Yeah, I think it's just a polynomial. I don't know what I'm doing. So why is this wrong? Why is my solution wrong? Want to study physics now? 10 hours, let's go. Yeah. Yes, sir. Alright, good luck with that, Sumaya. Let's look at the examples here. Yeah, I honestly don't really understand how that is the answer they got. E to t. Let me think. No, it makes sense. It makes perfect sense. So here you would get e to t times tb with no, yeah, this, and then e to t times e tb. This is equal to e to t times I, and we multiply it by this cosine matrix, right? And identity times a matrix is just a matrix, so we get e to t times this matrix here. So all is good. For some reason I got confused by the power series. 10 hours. Every time I feel bad about reading law, I realize it's still easier than this. Easier than studying 10 hours. I mean, I haven't studied law. I hear people always, like when I'm studying at Studio Centrum, it's called. It's like a place near my math department, and I constantly hear law students there, which is kind of funny. Anyways, let's I think that was it. 6. These are very computationally heavy questions, but I guess I'm fine with it since I'm really bad at computing stuff. My schedule? I don't really have a schedule set, but I usually start streams at around 7 a.m. or 7 p.m. 7 to 8 p.m. in my time, which is plus 2 hours UTC. Or it will now summertime will go back to regular time, so it will be plus 1 hour. So yeah. Okay, so we need to use theorem 4. So theorem 4, I'm pretty sure it's the Cayley-Hamilton, or maybe it's the wait, is it Cayley-Hamilton, or is it the other one? Oh no, it's this one, yeah. So can I recall this theorem? Okay, so we have sine of A, and this is equal to k0, so it would be 0. The first term would be 0. I think it's k2 plus 1. We'll just do some index, see what happens. 2k plus 1, and then x2k plus 1. So when it's 0, the first term is, there's no constant term. First term is positive, no, it's negative there. So it should probably be just 2k. And when it's 2, we get, wait, this is always even then. Maybe I'll just have it like this. When it's 0, and then when it's 1, we have let me just search it up to be sure it's correct. So it's a very odd one. I mean, for some reason, I in the back of my mind, I had it that sine is for even, like every even exponent, but yeah, it's not true. I mean, which makes sense as well, you know. So this should be true. Yep. So it should be negative when it's 1. Indeed. Okay. So we need to compute this, and I guess it doesn't matter if it's diagonalizable A. We just or can you even see the question? Yeah. So we're doing 6 here. And we have, okay, since this is 2 by 2, we need to let Q of lambda, I guess, or maybe I'll just do T, be equal to AT plus B. And we know by theorem 4 that right, so we need to find the eigenvalues of this. But then again, I'm wondering, what if it doesn't have eigenvalues? Like all functions don't necessarily have eigenvalues. I mean, at least real eigenvalues. Is that a problem? Is it a problem? -1 minus this 5 negative alpha 2. Because we need to input the eigenvalues, basically that Q of, we'll just call this eigenvalue lambda 1 is equal to sine of lambda 1, and then Q of lambda, right? So, and this should be the derivative. To be fair, it's the complex derivative, if I recall correctly. And this is the multiplicity of the first eigenvalue. I'm actually not sure. But anywho, this would be the n plus n1 multiplicity. I'm pretty sure. And this is for so if it has n eigenvectors with corresponding multiplicity n1, or I guess if it has m eigenvalues, corresponding multiplicity m n, this would be true for all q of lambda up to m dz n1 dn1. This probably is gibberish for people who haven't really looked at the theorem. I guess I understand that. And then are you first year? We learned this in first year of CS engineering. Finding eigenvalues, yeah. I'm in my second year, but finding eigenvalues is something I mean, yeah. It's a first year course. Am I doing practice problems? Yeah, I'm doing homework problems. Or like seminar problems. But I think this is correct how I wrote it down. So J is our index. Oh, maybe I'm doing it wrong. So here we have K from, so J can be, for example, 0. Oh, okay, yeah. So this would not be the case. It would be n minus n1 minus 1. Yeah. And it would also be an index between 0 and n1 minus 1. So no lectures today, no. I had 2 seminars, but I decided to instead do a longer live stream. Since, yeah, I don't know, I need the practice. I feel like, I mean, it's fine going to the seminars, and I hadn't really prepared that much for it, so I'd rather just prepare at home and skip it. Okay, this seems correct. I just want to recall that. Yeah. So I'm guessing lambda 1, lambda m they must be complex valued, because otherwise you wouldn't get the eigenvalues all the time. And we have q, which is a complex polynomial. I mean, I guess that's fine. There is a polynomial q of degree at most n minus 1. We have PA, which carries polynomial. Okay, I don't need to look at the proof, I guess. Let's not do that for now, at least. Maybe we can do it later. Your stream is the seminar, I guess. But it's not as scary. I mean, certainly not. Okie dokie. Yeah, so we have that Q, or firstly let's find the eigenvalues. So we have negative 1, 1 plus a lambda times 5 minus lambda, negative or plus 8. So I get lambda negative 5 lambda square negative 5 lambda plus 8. Or maybe there's a better way. Maybe not. Negative 4 lambda plus 8, no, plus 3. This is not really that nice. I'm expecting the solutions to be nice. Okay. Let's complete the square. We have plus minus 2. And then we have, this will be plus 2, or plus 4, so negative 4. So plus 3, that would be negative 1. Is equal to 0, so that would be lambda is equal to 2 plus minus 1. I guess that's kind of nice. So we have that Q of 3 is equal to sine of 3. Multiplicity is 1, and then we take Q of the other lambda, which is 1 sine of 1. We have that this is 3a plus b. Sine of 3 minus sine of 1. So b is sine sine of 3 plus sine of 1. And then what? Actually, what? Well, this is, wait, does the theorem say this? I should probably, yeah, this is what it says. Actually, let's go through the theorem. Like, this is kind of spooky. By lemma 5, so lemma 5 is the Cayley-Hamilton, which says that the characteristic polynomial of a matrix yeah, the characteristic polynomial of the matrix representation of the function is 0. Oh, right. I think this is just a division algorithm for entire functions. Yeah. So Q is at most n minus 1, and of degree at most this, and PA is of degree n, and this corresponds to the wait, let me just okay. All right, so if it's entire, we can write it as a power series. Okay, yeah, that's fair enough. Yeah, so they're just polynomials, and we can write f as a power series, which is just a polynomial. Fair enough. Well, I guess f of a would be this, and then p of a would just be 0. So it would make sense. We have that. For this q, we have that f of a is equal to q of a, exactly. Since is equal to this, which is equal to the product of PA is yes, of course. F of z and q of z have the same derivatives up to order nk minus 1 at z is equal to lambda k for all k, that is 5 is satisfied. Is it true? You can have the same derivatives up to nk minus 1. Well, yes. Right, so at lambda k, the characteristic polynomial is always 0. So we just have that they're equal to each other. Okay, well, I guess that's kind of an easy proof if we have the correct lemmas, I guess. It remains to show that condition 5 define the polynomial q in a unique way. Ah, yes. For that uniquely determined polynomial q for degree uniquely determined q. Assume therefore q hat is another polynomial degree at most which then q minus q hat is a polynomial of degree less than n minus 1, less than or equal to n minus 1. Okay, that has the zeros lambda 1 lambda m with multiplicity, where the sum is n. Thus q is 0, because a polynomial of degree with n0 is the null polynomial. I mean, I guess that's reasonable, a reasonable thing to say. I mean, okay, we have by the fundamental theorem of arithmetic, I think. Yeah, that all polynomials of order n have n complex roots, and if something with order n minus 1 has n zeros, I guess it isn't obvious, and we can probably prove it fairly easily. But why does the sum n though? I self-studied pure math back when I was 16. You got this? Nice. Thank you. Yeah, let's see here. Actually, I don't know why it's n. Why would it be n? We have that q is of most degree n minus 1, so surely it would have at most n minus 1 roots. Okay, let's just add ChatGPT. If you can give some insights. Because I would assume that the multiplicity or the sum of the multiplicity would be at most n minus 1. How do we know it's n? Like, we assume k is like, it doesn't really add up from in my head. Why is it that n1 plus n2 plus nk is equal to n in the proof of uniqueness in theorem 4. Working A with size n, its distinct eigenvectors are lambda 1, lambda m, each with algebraic multiplicity. By definition of algebraic multiplicity, the sum of the multiplicities equal the size of the matrix. I mean, okay, fair. I mean that I follow. monic polynomial of degree n. Its factors here, nk is algebraic multiplicity of lambda k, i.e. the exponent. Since PA has degree n, the sum of this exponent must be n. In the proof of uniqueness of the interpolating polynomial Q, suppose there are two polynomials, both satisfying condition, then their difference has zeros at each lambda k with multiplicity at least in k. Wait, does it have a zero? It has zeros lambda 1 to lambda m. I mean, yeah, the difference has zeros. Yes. Oh, I mean, okay, I guess that's, if you look at it, okay. Yeah, so there are n, n roots, and they're of order n minus 1. Okay, yeah, that makes sense, that makes sense. Yeah, cool. Cool. Okay, so we have sine of a is equal to sine of 3 minus sine of 1 divided by 2. I think this is a complex exponent, like complex polynomial, right? So like, I mean, here view q of z. So yeah, so z can be a complex value. Hashtag progress. Kinda listening as white noise while doing work. Alright. Yeah. You never know when you're gonna get through problems. Like I remember 2 days ago where I wanted to do understand the theorem about maximal solutions for ODE as well, but literally I spent 30 minutes, did not get anywhere, I don't think. It doesn't feel like it, at least. Alright. Alright, let's continue. Right, so now we have, so lambda 1 is 1, lambda 2 is 2 or 3. We have that. So 3a plus b is equal to e3, and this is just e, and this, yeah, so it would just be I mean, the answer would just be e3 minus e2z plus e3 plus e2. A12. Alright. I mean, A can be written as, okay, what are the eigenvectors? So we have negative 1, yeah, okay. Negative 1 minus lambda, 2, negative 4 minus lambda. Also depends on whether brain is clicking. Yeah, true. I mean, yesterday I was working on a, yeah, problem 5, and I just couldn't get it. It was past midnight as well. But now when I came back to it, it was kind of a lot easier at least. But yeah, what are you working on, James Grind? Is it another presentation or just your thesis in general? Like research. Okay, so okay. We have lambda 1 with 0, 4, negative 4, 2. It's 1, negative 1. And this could be equal to 0, 1. V equals 0, V2 equals 0. Figuring out how to approach a big step in my analysis because it's not very well defined by the field. Also meeting a postdoc later to discuss it. Okay, cool. Haven't been advancing my analyses in recent weeks, but came back into it. Like, what is the analysis? What do you exactly mean by that? Let's see here. Is this problematic? I don't know. So it's 0, 1, 1, negative 1/4. This is not really helping. Studying Technisk Matte at Chalmers. Truly feel like I'm dying. I love math, but I feel like so much effort is so fast. I generally don't think I'll pass the exams. Oh, okay. Well, I mean, first of all, congrats on getting in to Teknisk Matte. Like, is it too much material? Like, just like overwhelmed by info? I mean, for me, I felt that university is definitely, the pace is a lot quicker. Yeah, definitely. Okay, wait. I feel like something is up with my calculations. But I guess for me, I realized that, like, during my second year, life became a lot easier. Or it's certainly like, I'm guessing you started 1st of September. It's been like less than a month. So maybe try to stick with it more, and see if you can get used to it, like the pace and stuff, which I'm guessing the problem is. But yeah, I mean, I'm sure you're not the only one who's feeling this way. So maybe talk to other people, get some, I don't know, like, if you have friends, things become easier in that way as well. But yeah. Okay, so I guess our function here is 12. Okay. So we have that a. This seems weird. I mean, t squared isn't, or t to the power 12 is entire, right? So I guess the theorem applies. Working on spatial transcriptomics dataset, so I've done the pre-processing, but trying to move on to downstream steps by drawing biological conclusions, if that makes sense. Looking at differential gene expression, that sort of stuff. Okay, yeah, so you have some data. Okay, fair enough. Alright. I wouldn't know that much about that, but yeah. Good luck with that. Ay. Okay. So A12 would be equal to 3 to the 12 minus 3 to plus, or 2A plus 3 to the 12 plus 3 divided by 2. Let's see if my answers are correct by ChatGPT. Solve these problems. Compute ETA if A is this. I'm not understanding any of the pure math you're doing too. Yeah. All right. Eight. One plus 2 lambda plus lambda square lambda plus 1 square lambda 1 negative 1 and 1 2. Bro, this PDF or like this whiteboard document is so long. Oh man, it just keeps going. I should probably structure my notes a little better than just it's like a tower of notes. Or maybe not. Tower of text. Okay, so we have that given Q of Z AZ plus B, where Q is a complex function. We have that Q of negative 1 is equal to E negative A. We have that Wait, this makes no sense. This is a matrix and this is a polynomial. Go horizontally sometimes. I should draw like a picture of like a smiley face. If I now continue to go going right and do like a square of nodes. Okay, that will be very confusing. Or maybe if I just go down. I can go down like this and down like this. Never mind. Yeah, this is not making much sense to me. This would be A, E, like this. Or do I just multiply it by the identity matrix? Da Vinci? Wait, I think, yeah, here's a similar problem, I think. We have double here. Wait, why? Oh. Okay, yeah, true. Yeah, this is just equal to a scalar times this, and we can just consider this on its own. So we don't have any issues, to be honest. We don't have any issues whatsoever. And this is equal to negative negative a plus b, and then b, I guess. No. A. This is if and only if b is 2e, I guess. We get e a is equal to e a plus 2e plus. And then e t a is just equal to t a k. And yeah, this we can. Wait, is this correct actually? Yeah, I guess this would be the same as if we have the identity here. Then I would agree. Yep. No, what am I doing? If it's the identity, what am I doing? I mean, would it just be t here? I mean, I guess so. It's just a scalar, right? Wouldn't change anything. I don't think so, at least. A scalar wouldn't change the eigenvalues or vectors, so yeah. In that case, it wouldn't do anything. Yeah. So it would have the same representation. Let me just check the thing. A double, we consider I find it fairly weird. They solve it with a t there. P of lambda is equal to A is equal to this. Alright, yeah. And these blunders, I blunder so much. What's going on? We have E negative T. Joining in, welcome Young Cook. Right. So we have a T there, but is that really a problem? I'm not sure what they're doing here. So we have Q of 2, Q2 is equal to this. We have prime is, right, so prime, we have a T there. And then, boom. So we have Q lambda is equal to that. Our second degree polynomials which fulfill, so Q of lambda is equal to something times E negative T plus P1 lambda E T negative ET so we have that P1 of lambda is But okay, fair enough. Maybe it's easier to do with when it's like a second order one. I mean, here Q is just A Z plus B. So I mean, this seems like overkill. We can do Q of AZ plus B is equal to E. So A would be, then we have this, which is just equal to A. Negative is equal to T E negative T. B is equal to E negative T plus. Like that. Let's see. When Z is -1, we have, yeah. And when Z is okay. I mean, this seems like a peculiar method, but I guess fair enough. Or wait, is it even correct? Yeah, this should be correct. This should be T there, and it should be that. Yeah, okay. Okay, that makes sense. Q of A is equal to equal to ETA. Okay. Alright, web A is this. Alright, it's almost gone 2 hours. I think I'm just gonna take a break and grab something to eat before moving on. Or maybe I'll do maybe this one and then I'll move on. Go for lunch, alright. Remember to take breaks. Yeah. Alright, see you. Good luck on the meeting with the postdoc. Alright. Yeah, let's just do this one first. So we need to calculate this, and this is a function f of a. I did this mistake, I'm thinking of this as a function of t, but t is just a constant. We don't need to think of it as a function there. Try diagonalizing the matrix, helps in some cases. That is true. I mean, I guess this is a foolproof way. Or we didn't say foolproof. I mean, you can't mess up. I mean, this works generally for every matrix. But I mean, if the matrix is nilpotent, you're golden. But this probably is not nilpotent. I still don't really know. Or no, it's not nilpotent since the determinant is non-zero. Yeah, determinant is 2, so it can't be nilpotent. And if it is diagonalizable, I mean, granted, I'm still not really that familiar with when a matrix can be diagonalizable, because in this case, I think which one was it? I think it was this one. Where which one was it? Yeah, so here the eigenvectors or eigenvalues were 1 and I think it was 1 and 3. I know that when A is written in its diagonal form, it's kind of easy. Same with nilpotent matrices. Yeah, exactly. But like in this case, we have lambda 1, lambda 2, or lambda 3. But when we try to find the vectors, if we have this one, I think, yeah, this one was 6 here. So, or let me check. Yeah. Or no, actually it was 6. If we put 1 here, we get -2, -4, and we get vectors. Like I had the idea that if we have 2 distinct eigenvalues, then we have then it can be diagonalizable, right? I think that's what I wrote here. If A has n simple eigenvalues, it's diagonalizable, but in this case it doesn't seem to be diagonalizable. Man, my linear algebra knowledge is apparently not that good. I'll just ask chat, or maybe someone can help in the chat. Someone who knows linear algebra. Is this matrix diagonalizable? The eigenvalues are 1 and 3, but when computing eigenvectors, I get 0, 0. I mean, this would be the trivial, like, since a matrix, or I guess that's not correct, but rather if for every linear transformation, yeah, it's linear, right? So this is always true that the 0, 0 matrix or vector maps to the 0, 0, 1. So it's a trivial eigenvector. Yeah. I don't know what I'm saying. I guess I'm just speaking and seeing if some linear algebra theorem just, or knowledge that is deep in the brain pops up. It is diagonalizable, but what are the eigenvectors, bruh? Am I dumb? Maybe I'm just computing it wrong. Oh yeah, I mean, in this case, you would get... yeah, okay, well, I guess I just computed it wrong. I mean, yeah, I mean, okay, my bad. Yeah, otherwise it wouldn't make sense. Let's move on from that. Anywho, so let's do some stuff. I guess it's kind of convenient actually to have it like this. So it's 0 or 2. Yeah, I mean, okay, so in this case we get a basis. I mean, let's try your way, Ray LL. Let's do that. It should work out pretty nicely. Yeah, it should work out pretty nicely. So if it's 0, we get 1, negative 1, 1, 1, which is equivalent to why am I getting the trivial matrix? I mean, in this case, if it's 1, get negative 2, we get 4, and 2. Invested in my own homework, fair enough. Hum. Oh, I'm dumb. Wait, this has no eigen. It has no. Yeah, I didn't calculate that correctly. So that it's equal to 1 minus this is equal to I. I mean, we can do this minus 1, which is equal to I. Yeah, it's plus minus this, so it's 1 plus minus I. I mean, in this case, it would be with complex, like would be a complex vector. I haven't really practiced a lot with complex values, though. I think I'm just gonna do the one like the previous method. I mean, let's try it. Let's see what happens. So we have 1, so we get negative I for lambda equal 1 plus I. We get 1, negative 1, and then we get negative I. What do you do here? Crap, does this even work? I mean, I guess this becomes negative I squared, so it's 1 negative. Wait, is that true? What? negative I equal to 1 over I. We have negative, I mean, I guess that's true. Okay. That's just 0. So V1 is equal to 1 over I of V2. I've never done this before, but I have a faint recollection that it should work. Wait, one. Well, this seems like a contradiction. No. Or I guess these are two options for it. Oh, okay, well, maybe not actually. So vectors on the form v1 or rather I v1 plus minus v2. And then you can create these vectors. I mean, maybe it would work, probably. Let's just try the normal way, I guess. When you have this, I mean, the eigenvalues were 1 plus minus I. Let's just do plus I, which is equal to this. And then this is equal to E ET 1 plus I And then we have q1 minus I. And I guess we can subtract them. We would get 2a 2ia is equal to all right then. I mean, yeah, this is just more straightforward, I would say. But I actually want to compare my answers if you actually get the same answer. So B would be equal to oh, is there a way to simplify this? When E of I is equal to well, I guess it wouldn't be that nice to be H. Yeah, it would be like the angle would be 1, so you can really simplify it that much. I don't think this could be simplified that much, or rather, yeah, of course it could be simplified. What am I doing? What am I doing? We can multiply this in. Method that seems to be working is decomposing A. Like, how do you mean? Into like, you can use the like the Cayley-Hamilton idea, or you can use by decomposing it into like finding the vectors. I mean, eigenvectors. But yeah. My brain is working at like 1 mile an hour. What were the like sorry. All right. Alright, so yeah, this is equal to sine sine of 1, right? So we would have this minus let's see here. This will be equal to I think that's how you do it. Alright, my brain is kind of fried. I'll continue after a lunch break. Still kind of a lot of questions left, and I want to do some of the proofs in the chapter as well. I feel like I'm going quite slowly today, but it is what it is. I have a long day ahead of me, so I don't think like time would be that much of an issue. Got the answer. I don't know if it's the right though. Yeah, me too. I think this is right though. I mean, if you use the Euler's exponential like formula for sine here, it kind of simplifies nicely. But how did you do it, Rail? If you mind explaining. I'll look at if you do write it down in the chat if you have time. I'll look at it after I come back. But I mean, yeah. Otherwise, you would have to calculate ET of A. You can like you can find the diagonalize it. So D would be 1 plus I, 1 minus I, and then I guess you would define T to be for example maybe wouldn't I0 be for both? But I guess you wouldn't choose that. I guess you can choose 0 and then 1, maybe. Would that work as a basis? Actually, I'm not sure. What would a basis look like in this context? I mean, a basis normally would be the amount, or like two vector linearly independent and they span the space. I'll write down what my issues. What does it mean? Or maybe rather, all right. I'll be right back. I'll take a break for lunch. All right. I'll see you guys in around 30 minutes. Alright, that was that. I think I was out a lot longer, maybe like 50 minutes. But hey, I needed to like cook food and everything, so can I? No, okay. Yeah, the touch on my laptop is still broken. Hello, user. A is equal to I plus J sort of thing. J's rotation matrix, I and J commute because J squared is I negative I. Exponential expands like sine and cosine. And then I think I messed up. You should try though. Oh. Rotation matrix, okay. Interesting. Let's see here. All right, I think I'll just continue. I mean, I guess that's interesting. I'm not really sure if I can recall exactly the form of a rotation matrix. Actually, I think this is a rotation matrix now that I think about it. Isn't this a rotation matrix? Is J square what is I then? Anyways, I think I'm just gonna continue. Now we have for 3x3 matrices. Alright, well, this is a symmetric one. I'm not sure if I'm really that bothered to calculate this. Wait, there's a corollary. Every element in ETA is a linear combination of terms of the form TJE lambda T, where lambda is an eigenvector of A and J is less than the multiplicity of the eigenvalue. Coefficients will be linear combination of such terms by Cramer's rule. Alright. I think I want to do 8 or 9, seems pretty interesting. So ETA f of t f of 0 inverse alright, so we have that F is the fundamental matrix of the homogeneous system. This I need to show this. Okay. Yeah, this is yeah, okay. Well, I did those correct. Yeah, let's ask AI for the solutions for these ones, since there isn't really a like a solution sheet given. I'll solve these ones as well. So I think that the solution of this homogeneous ODE is just EA, or actually it's not. Wait, what was the solution? Yeah, it's supposed to be t here, and we have f of t here. And then the derivative would be this. Yeah, by this theorem 3. Okay. Let's see here. So oy. Okay, so the fundamental matrix is of the form x1, x2 up to xn, where these are all solutions, xn1 up to xn. Right. I think we have f prime of prime is equal to a fx or f. This would be a times f, so a1 and then this times this. Wait, this doesn't seem correct. Try solve the other 2 questions too while you were gone. Nice. How did that go? Like 8 and 9. I need to look back at the previous chapter. By the way, were you studying math, Rael? Are you doing a bachelor's or what? Okay. Seems like you got this down. I cannot say the same. I'm kind of struggling with these questions, honestly. Let's see here. Or no, it was. This is the way you do it, but for some reason it doesn't really make sense to me. Why it doesn't make sense to me? Oh, I guess it does. Yeah, sorry. Yeah, true. Okay. Will this help me? That's the question. Maybe not. I don't really know where to start, to be honest. So we have that. Currently pursuing. Not pursuing masters, but I learned ahead of time. So you're doing your bachelor's in math. Yeah, cool. What year are you in? Like, Alright, well, I guess we can just... Okay, we know that it has a unique solution. So if we just try to differentiate it should work. Or it should be equal to that. I'm thinking. We have f inverse of 0, which is a bit weird. Hello, Levy. Welcome. Theoretical physics and CSE. Are you in your second year or what? Let's see here. Oh, okay, yeah. This is okay. Yeah. So I guess it is a solution by uniqueness. ETA is equal to FT. That's first year. Nice. Well, impressive that you're doing second year problems. You'll be very yeah, you're definitely ahead. Let's see here. Oh, I think here you're doing. There's like a complex eigenvalues. Okay, maybe I'll read that because it could be useful in this scenario. Like learning ahead. Yeah, I mean, I guess that's fair enough, but nonetheless, it's impressive. All right. Compute sine of A is a matrix. Alright, I think I'll skip this one and I'll just move to another subject. Or actually, I did miss a lecture. I think I'll just do that then. Yeah, course plan. So 2.2, 2.3. Homogeneous systems. So I had maths paper, and it's first time in my life I feel like I'm going to fail this one. Oh no. Well, hopefully that's not the case. And yeah. Hopefully you'll get a pass. Yeah, nonetheless, hello Jaya, I don't think I've seen you today. Hopefully things are good, other than, you know, the stress from the exam. last paper, or yeah, it's a paper rather. Alright, homogeneous systems. The unique solution of the initial value problem is x of t right. Right, so x of t, that's 1, and we get a of x naught. Wait, what is a x naught? So, I guess we just input x of x naught instead of t. Tomorrow I have another exam. Alright. Good luck, good luck. Mid-semester, scores will count, but I have to do much better in the end. Yeah. Yeah, certainly the final exam is the most important. Okay, proof. I'm not sure what ax naught is. We know that eta is a fundamental matrix of the system. The general solution is thus etc times c. Let's see here. C is an arbitrary column matrix. All we have to do is choose C so the initial condition is fulfilled. And that will be e to the negative t naught. Or wait. Oh, okay, I read this wrong. It's the power to the power of a, and then we have x naught there. Well, that is interesting. Oh, I read that completely wrong. Yeah, so this would just be, yeah, okay, well that makes sense. Solve the problem. This is that. Okay. So let's see here. General solution is t minus t naught a x naught. So we have x prime is equal to 1, 2, 2, 4 of x. Initial solution is 1 is equal to 3, negative 1. So I guess you would find the exponential like we did before, and since it's symmetric, we can find the eigenvector technique there. Gotta go. Also was my first time on your channel. Keep it up, good work. Thanks, Rail. You are very welcome to join again. Yeah, wish you a good rest of your day. Alright. Eigenvector is 5 and 0. So we can rewrite this as that. check of computation is d dt alright. I recall. Right, so we have lambda 1 is 0, lambda 2 is 5. E 0 here, which is equal to 1. I think this is correct. Oh, wait, yeah. Right. Have this A. This will be equal to 1/5 E minus 1 5 minus 1 plus 1. I think so. Oh, and this will be A here. I guess okay, I'm tweaking. Okay, 5 or E5 T minus 1 A minus 1/5 all right, there you go. Okay, we have E T minus 1 A of 3 negative 1. Okay. Okay, theorem 6. Assume V1 up to Vn is a basis of eigenvectors of matrix A, and lambda 1 to lambda n is corresponding eigenvalues. Then the general solution of the system can be written as that. Oh, okay. Proof. The general solution is x of t is equal to eta c. C is a constant column matrix. A is diagonalizable. We have okay. Where the invertible matrix T contains the eigenvectors of as columns, thus T E T D. Yeah. Oh, okay, yeah. So this is the same as multiplying this in. So get C. Oh yeah, it's a diagonal one. And this is the same as multiplying V1 on each of those. Yeah, fair enough. Whichever multiplication is carried through becomes 6. Proof 2, we give another proof. All functions solve the system because yeah. Functions t from this are linearly independent in the solution space. Since t is not, they are linearly independent in Cn. Therefore, they form a basis for the space. Since it has dimension n, according to Theorem 4 in chapter 1, page 48. Follows that an arbitrary solution is of the form 6. It is instructive to see yet another proof. Change of variables. Original system of coupled differential equations. The method in proof 3 also works for inhomogeneous systems. See example 9. When A is not diagonalized, terms of the form appear in the solution. This follows from the general form of ETA, the corollary on page 101. With the last remark, the proof of Theorem 2 in chapter 0 is completed, namely the first order system according to equation is represented by a matrix whose characteristic characteristic polynomial is L lambda. The eigenvector 1, 2. Thus the system has the solutions. Let me write this down. So we have the x of t is c1, or the sum. Well, that makes life very easy. we just need to find the like eigenvectors and eigenvalues, then we're basically done. The condition x of 1. But can ODEs be of the form that they do not have eigenvalues? I mean, I assume so. Then we can't use that theorem, right? General solution of system can be written. Yeah, I think so. So if I just ask ChatGPT, what if the matrix A of a linear ODE is not diagonalizable. I mean, I still kind of find it kind of crazy that all linear ODEs of like any order has a unique solution. That's kind of insane. Like, no matter how we construct it, like no matter what coefficients, it will always be a solution. Like, I can construct anything like that, and this will have some kind of solution. That's kind of insane. Let's see here. But yeah, so certainly a linear ODE can have a matrix A such that it's not diagonalizable, since like all linear combinations, or like all ODEs, like no matter what coefficients they have, has a unique solution. So that makes sense. But in that case, we wouldn't use theorem 6. I'm pretty sure, at least. They would have different forms. Yeah, I think that's fairly obvious. I don't need to ask. All right. Proof 1. Okay, complex eigenvalues. In the preceding discussion, complex eigenvalues and complex eigenvectors may, of course, appear. Now assume that the matrix A has real elements, then lambda eigenvalue implies lambda bar eigenvalue. Since the characteristic equation has real coefficients. Wait, what is lambda bar? Oh, it's the conjugate, right? Okay, fair enough. Yeah. V eigenvalue to the eigenvector V conjugate because if y is not real, v and v bar are likely independent since they belong to different eigenvalues. When A has real elements, we are usually only interested in real solutions. AV plus AV. Right, so A real implies V and U are like lambda can be complex and V is complex. We are usually only interested in real solutions. If x of t is a complex solution, then the real of x and the imaginary x are also solutions. It's a complex eigenvalue, then it corresponds to a complex eigenvector. The real part of the solution is equal to real part of x. Where the v omega is sigma plus I. Imaginary part is given by a similar expression. When sigma is less than 0, every component of the real of x and imaginary of x constitute a damped oscillation frequency with frequency omega divided by pi 2. Omega is negative. A homogeneous linear system is called asymptotically stable. All solutions tends to 0 when t goes to infinity. If all solutions are bounded when t positive. Okay, asymptotically stable. So it goes to 0, and then x of t bounded. If all eigenvalues of matrix A have a negative real part, the system x prime of ax is asymptotically stable. Have a negative real part. We have that this equal to this. goes to 0. Okay, fair enough. Yeah. In the general case, the solution contains terms of the form, but this makes no difference. As an application, you're interested in the question: does the characteristic equation of a certain matrix have all its roots in the left plane? For system of order 1, 2 characteristic equation is of degree 1, 2 respectively. And this is of course a simple problem. In the general case, such problems can be investigated by the argument principle. Argument principle. We do mention that there is a criterion by Ruth and Hurwitz, which, for example, for a third degree equation with linear real coefficients, says that it has all its zeros in the left half of the plane if coefficients are greater than 0. Okay. Alright, cool. Okay. Alright, well, I guess that's all the questions for ODE. I think I'll just move on then. I guess I could try to solve these problems. Oh wait, there's also chapter 2.3, right? Yeah, okay. Inhomogeneous solutions. Let's see. Discord. We just Alright, I did ask for lecture notes on the Discord that my class has. We'll see if anyone has responded. Ay. Honestly, it feels like this ODE stuff never ends. It never ends. Alright, I'll head to the bathroom in the meantime. I'll be right back. Alright, cool. How to learn math? Please, I need help. That's a very good question. I mean, I guess it's mostly repetition, right? I would compare it to like anything else. I mean, if you want to get better at drawing, you should draw more. And I guess there are probably some things you should focus on more. And when drawing, like the fundamentals, perspective and stuff. And I guess when it comes to mathematics, like the fundamentals is probably like basic algebra, and then moving up to some analysis, like one variable and then some linear algebra and stuff. So I mean, usually the normal curriculum you have is I guess fairly decent, but yeah, it's just practice. And if you don't feel confident in a certain topic, you just try to constantly do stuff that you don't feel comfortable in. Like yeah, it's all about practice. I'm not sure if you've seen the meme like with what is it? It's all about the it's all about practice, not the game. Meme. Yeah, Allen Iverson. I guess one. I'm not sure what the game would be, but it's all about practice. It's all about practice. Okay, has anyone responded to me? No one responded. Fantastic. Alright, biscuits. Okay, general solution methods. We're going to present some methods for finding particular solution of the system. Here A, as before, is a constant by matrix, and B is assumed to be a continuous function from R to Cn. Okay. Oh, I think I've mixed my something up here. So A is constant, doesn't depend on T. Wait, did we consider when it did depend on T before? Yeah, we did, I think. Using the fundamental methods, we can give a formula for the solution of a eight-dimensional system where A of T, A is a function of T. Yeah, okay. Oh yeah, this is the entire chapter too. Linear systems with constant coefficients. Okay, well that makes a lot more sense. So this is only for those scenarios. I'm back. You started solving questions yet? Yeah, I finished up until question 10. Or actually I kind of skipped that one, but just to save some time and energy. But yeah, I'm on chapter 2 and 3 now. I just realized that A is always assumed to be constant, yeah. It does not depend on T. So this is just like a subset of of ODEs, or like linear ODEs. Okay, fair enough. What is my favorite method for solving ODEs? I mean, I guess the only method that is presented in the book, at least, is the one we just did with like the matrix exponential. But I mean, I guess the most simple one is when you can where you can split up the ODE to the side that depends on t and the side that depends on x. That's nice. Very, very easy and nice. All right. Here A as before. Okay. In Theorem 5, in Chapter 1, we set a formula for solution of linear systems of differential equation when A is constant. ETA is a fundamental matrix. Yeah. Let me see that matrix or that theorem. Wait, Theorem 5? Oh, here it is. Yeah, right. When A is constant, ETA is a fundamental matrix. The formula becomes x of t is equal to f of t, t naught t. So we have this. And the fundamental matrix becomes ETA. Right, since this solves the homogeneous one, this would be this would make sense. Okay. As an alternative, when A is eigenvalue, you can do as in proof 3 of theorem 6. Introduce new unknowns x of y, where t is a matrix. Diagonalize A. We arrive at a system with independent equations. Solve equations. Let's see here. X prime is equal to -2, 1, 1, -2, x plus e to t 2 e to t. You're talking about separate ODEs? Yes, exactly. I kind of lost the name, but that's exactly what I mean. I mean, it's the most simple case, I guess. But yeah, I mean, I'll see. You can ask that question when I'm done with this course. Alright, so the general solution would just be this. So I guess the goal is to find this expression. Yeah. So we have that E of TA is equal to I guess this is just a similar method as we did before. I'll just skip it. So we have this, and then 8 implies that we can just write this as this, and then we integrate yeah, note that it is wise to wait as long as possible to put in numbers. You find the general solution by adding an arbitrary solution of homogeneous equations. Finally end up with where d1, d2 are arbitrary constants. So you would add the homogeneous one, which is wait, let me wait, what? I don't really understand this last step though. like, how does the homogeneous equation look like? I mean, it would be like, are these the eigenvectors? I guess they are. These are the eigenvalues, right? So 1 1 would be -2 1 1 -2 1 1 is equal to -1 -1. So it has eigenvalue 1 or -1, which makes sense here. Yeah, so this, okay, it seems highly convenient. Okay, well, I guess this would be equal to 1 5 e to t 2 3 and we have that the homogeneous solution is precisely equal to this. My YT algorithm loves you. Awesome. What's up, NN18? Hopefully you're doing well today. I don't think I've seen you in today's stream. I don't think so. We're doing more ODE today. I think I'm gonna stop, honestly, in like a couple minutes. I want to move on to another. I have some stats question I also want to do. I hate that I'm almost out of frame. I need to be like, maybe I just twist it a little like this. How about you? I'm doing pretty well. I went to bed yesterday at like 1:30 a.m. and then I woke up at 6 a.m. today. So I got very, very little sleep, less than 5 hours, which I'm not bragging about. It's really, really bad, and I do not recommend people doing it. But yeah, I'll try to today, like, go to bed earlier and stuff. But nonetheless, I'm feeling kind of tired, but today is going pretty well. I also had like a driving lesson today, and I'm feeling a lot more comfortable behind the wheel, which is always satisfying, seeing progress, I guess. But yeah, that's basically all I've done today: the driving and this stream. So this would be the particular solution, and this would be like particular. This would be the homogeneous. And I guess the author writes it specifically in this form, where we have the eigen, or this is just a constant, right? So it's not really. I mean, you would have it a constant times e, the eigenvector t, and then the corresponding eigenvector here. So this is just a constant, and you want the linear combination of the homogeneous solution. Okay. Keep up the good work. Thank you. Okay. Find the general solutions by adding in, okay, blah blah blah. Finally, and blah blah blah. After some computation, we arrive at the factorization. Wait, we have -1, -3. Oh, we can solve it using another. Well, this is a kind of a spooky technique. So we get t prime is equal to t dt x plus b. So we have the inverse there. Prime d tx plus t inverse bt. And then we set y to be equal to this. Y is equal to, which implies that y prime is equal to this. So we get y prime is equal to, wait, what? X is equal to yt or ty rather. What? Oh yeah, of course, we had the inverse here. Okay, that makes sense. Yeah, so we get dy plus t inverse bt. And I should set a sub goal. I'll do that now actually. If we reach, I guess, 1 super chat within the next 2 hours, what will I do? I think I'll do like 150 push-ups. I think I can do that. I'll do 150 push-ups. I've been practicing my push-ups lately. So yeah, feel free to suggest any other goal if we reach this 1 super chat this stream, or in the next 2 hours, I guess. I think I've heard many people say to try like a GEE exercise or like a exam. So maybe I can do that as well, or instead of the push-ups. Right, so I need to solve negative y 1 plus right, so our b is equal to 1/2. Okay, yeah, so we get 3 e to t y2 magnitude and I guess we can just solve it by just, or actually now that I just got thought of an answer to your question, Spider Boy. I'm not sure if you're here, but solving ODEs via the Laplace transform, that was something new to me, and it was fairly nice. So that's, I guess that's my answer. I'm not sure if you can generally do it. I mean, the ODEs that I solved, like using Laplace transform, is I think only linear. Granted, I'm not really sure. I want to investigate that maybe later on in the stream. GE Advanced, right? Pretty hard for a normal high schooler. Yeah. I've heard it's probably like one of the hardest entrance exams you can do in the world. I don't think I'll be able to do well at all in that exam. I think I'll do pretty poorly. I'm not gonna lie. But granted, I've never seen any question from it, so I don't really know. Yeah, so we can solve this with integrating factor. And then you get this. Okay, so you do the integrating factor business. And you get 2t c1 et. Going back to original variables, we have oh yeah, I guess we just do the matrix. So we get x is equal to transition matrix, which is what was it? 1 square root of 2, 1, 1, 1, negative 1 times the solution here, which is alright. And you get the constants for free. Exponential right hand side. We will now make a particular study of the case when bt is of the form e mu tb, where mu is in C, and B is a constant column matrix. It is then natural to see the solution of the same form. Should try attempting it though. Questions are usually based on usual high school concepts, just made trickier. Also, given the time limit, all of these factors make it pretty hard. Yeah. Have you done it, Rail? Or Rail? I gave it right after high school to get into my uni. Nice. I mean, I did do like a Swedish equivalent, or I don't know if you can even say it's equivalent, since I feel like it's a lot easier, but yeah, there's like a SAT version, like Swedish version of the SAT, that I did, but I'm not sure if it's even comparable. I mean, there's only it's not really science focused, to be fair. So yeah, I mean, that's the only practice I've had with like extreme time limits and stuff. I mean, usually exams in high school for me are given like very generous time limits and stuff. Okay. Is the natural solution of the same form? E mu to b. So when b of t is equal to e mu to b, mu is constant. So it's some real column matrix. Hello Layla, welcome. Okay, so we want if only if ui minus a u is b. I guess so, yeah. Matrix is invertible, that is, if mu is not an eigenvalue of A, the system of equations has a unique solution. If the matrix, okay. Consequently, the system 7 has solution of the same form of B. Right, so it would be the inverse. So t is equal to u mu of t, and then you have the u. Okay. I mean, I find it kind of weird, but fair enough. I don't see how it's natural to find a solution where x of t is on the same form as b. If u is not an eigenvalue of A, the system has particular solution. The matrix is called the resolvent matrix. When mu is an eigenvalue of A, the system has no solution. Right. given new not eigenvalue I mean, if it is an eigenvalue, what happens then? Right, so this would be the characteristic polynomial. When using like the system has usually no solutions, in exceptional cases infinitely many, depending on B. Yeah. In general, the solution 7 will contain terms of the form resonance below. Put at least 2 super chats. I mean, the stream is gonna be long, so I mean, YouTube only allows 1 or 3 super chats, but I mean, I can aim for something higher maybe, but I don't know if that will help. I'll try to. We'll do 3 super, or no, even it's either 1 or 5 super chats. Okay, if I get 5, how many push-ups? How many push-ups does 5 super chats? Do I have to do if I reach 5? I mean, I'll do like 500. Not gonna lie, I'll be here for like. Okay, maybe 500 is too many, but. I mean, I'm not sure how long 100 push-ups took before. Probably like 10 minutes. I can probably 500 will take 1 hour. Probably have to do intervals and stuff. I've never done that many push-ups. Okay, I'll do 250. Booyah. Booyakasha. Got calculus T this semester. I'm shaking. Good for you, you're doing there. Alright. Well, good luck on calculus 3. I mean, I'm not really sure what you do in calculus 3. But I'm guessing it's maybe Green's and Stokes theorem. You're saying you can do 500 push-ups? I mean, not straight, like I with breaks in between. I'm not that strong. I can probably do like 50 push-ups without, or like 60 something without breaks, but yeah. I mean, I think I've seen people do like 5,000 push-ups or something without any break or something. It's crazy. I don't know how people do it. 19 studying physics and electrical engineering. So it will be another 8-hour study day. Love it so much. Awesome. Well, good luck with that, Fritz. Fritz. Okay. But yeah, I wish I had like a pull-up bar. I mean, pull-ups. I think pull-ups in general are more fun than push-ups. But I don't want to mess up my the door frame. Probably I'll buy a new pull-up bar that doesn't break my frame like my door frame. Let's see here. I mean, okay. When mu is an eigenvalue of A, the system of equations has usually no solutions. What? If A is not an eigen, the system has the particular solution. If the matrix is invertible, that is, if mu is not an eigenvalue of A, I don't really get that though. I don't really get that. Let's ask ChatGPT. Yeah, let's do that. Why is it that if mu is not an eigenvalue of A, then mu times minus A is pull-ups are more rigorous though. I mean, yeah, you can't do as many pull-ups, but I don't know. I feel like they're more fun. I mean, in a way, it's like, yeah, it becomes more like fun when you can't do as many, right? I would say. I blame my poor hand strength. No, but they're like pull-ups are in general like a difficult exercise. So I think it's like the absolute minority of people, like less than 1% or something, they can actually do like a handful of, or like a couple pull-ups at least. So it's definitely like it's difficult. I don't understand this text. It's very confusing. What sports do you do? Have you kept up with them during uni? I don't really do any sports. I rather just go to the gym, and to be fair, I used to run a lot, but now I'm actually not running any. Like, I'm not running at all. Granted, I think running is kind of fun, especially races are really really fun. But to be fair, I do want to go up in weight, and then I'll probably do some more running. So that's basically all the like physical activity I do. I mean, in a way, I find sports kind of, I don't know. I don't know if pointless is the right word, but it's something like that. I don't really want to spend my time perfecting. Like, I guess you can do sports for fun. Like, I play ping pong or table tennis once, during breaks in at the university. And stuff like that. But and I guess basketball is kind of fun as well. But other than that, I can't see myself ever playing a sport like actively and trying to get better at a sport. Like, I find it more interesting improving like my physical, like my physique, rather than skill dribbling a ball or something. I guess that's what I'm trying to say. And I think that's why I enjoy like going to the gym and running. There isn't really a focus on technique other than like becoming stronger. Everyone climbing? Yeah, climbing is really fun. Yeah, I have gone a couple times. But the only downside is that it's really expensive. Get back to multiplying matrices like there's no tomorrow. I mean, look, I've been streaming for 5 hours. I think I can take breaks once in a while, But yeah, I mean, otherwise climbing is a really fun sport. When I actually have a job, I think I'll do some climbing, and when I actually have an income. Okay. It's also like a really good exercise for like your forearms and back as well. So it's not all like merely a sport that is where you need skill and stuff, but it's also a lot of strength and stuff. But a good place to decompress. I mean, yeah, sure. I used to climb a lot in at a like a there was like an outdoor climbing place near a park here in Lund. And I remember, I think it was two years ago, like during the summer break, I used to climb every day there after the gym. I think I posted a lot of shorts during those days as well, like with the Discipline Life series. No water. Okay. Example 9. Okay, we can have another solution method. X of t is equal to e2t u1 u2. So give 4, -1, -1, 4. Oh, what is... Okay. Did we read this? Did I read this? The only solution to this is x is equal to 0. Rearranging gives ax is an eigenvector and mu is an eigenvalue. It's a contradiction. Okay, I don't think he answered my question really. Let's look at this. So we have -2, -2. U1 is equal to oh wow, okay. So yeah, we get this one. Applicable also when b of t is a sum of different exponential functions. Since the system is linear, you can solve it separately for each term, then add the obtained solutions. In particular, it follows that we can treat the case when the elements in Bt are trigonometric functions. The general solution of this is the sum of the particular solution and the general homogeneous system. But x of h goes to 0 when t goes to infinity. After some time you will in practice not see anything measurable of x of h. The solution x of t for practical purposes will contain only the particular solution 10. Okay. In the case for an asymptotically stable system, this represents the solution as soon as the transients expire. The reader might note that solution 10 independent of initial values. Wait, what does transients mean? Let's take it here. I don't really get that. Passive alternating current. Man, this is physics. Oh, we have a circuit? Transients are short-lived parts of the solution that die with time. Oh, I see. This representation, the solution as soon as the transients have expired. The reader might note that solution 10 is independent of initial values. Alright, I think I will stop here with the ODE. Yeah, okay. Our document is hella long now. Oh gosh. Okay, that's pretty long. Let's see here. Alright, let's do some statistics. Some stats. Ay, ay, ay. Where are my files? Okay. There we go. Alright, then after stats we'll do some convolutions. Yeah, convolution. Here? Yeah, okay. But we'll do that afterwards. Alright. Stats. Let's probability theory, Evans Rosenthal's. Click. Click. So in week 3. Oh, there are a lot of problems. We have some challenging problems as well. Oh, I need to log in. also want to see, there are some more advanced books. Let's see if I can log in here. Alright. Alright. Huh. Okay, apparently these are some more difficult questions as well. Ay, ay, ay. I'll put some music on so I don't fall asleep. Like that. There we go. Alright, so we have U as a uniform distribution, so 0, 1. Y is a random variable U divided by 3. What is distribution of Y? Alright, I wanna I have some questions with this question, like what does the inverse transformation theorem? Wait, what is that? Yeah, and then 18, you have to help me with this. Like when saying that U is like uniformly, does what exactly does this mean? I'm having a hard time understanding some of the definitions and stuff in stats. Maybe I'll go back to these chapters. I mean, this is it's a uniform distribution, meaning that yeah, whose distribution is a uniform distribution as presented, that is probability. Like I thought of, like, is a distribution a function or is it a set? I think previously I wrote it as a set, but I don't know if that is the case, you know? U is distributed as a uniform on 0, 1. Formally use a random variable with probability density function like that. And its CDF is FU. Okay, I should probably read and go through the definitions again. Use a random variable which is distributed uniformly on between 0 to 1. Basically, you observe any interval AB, subset of AB with probability B minus A. I mean, I guess I understand that, but saying a random variable is distributed, okay. like the probability here of the random variable to be between 1/2 and 3/4. I mean, I guess the idea of a random variable is also fairly weird to me. Like, it doesn't make intuitive sense why you would call a random variable like a function from the sample space to 0, 1. Doesn't make intuitive sense to me. Not. You as a person observe a number at the end. For you, U is the measurement from a source of randomness. But behind the observation, there is a law of U, which governs the distribution of values. Okay. Oh, so you measure like the output of X. Is that the idea? So you measure a value from 0 to 1, and the idea of random is to hide the source of the randomness. Behind a function you can then ask general questions about. Is there like an example, like like what is the observation in this case? Like, I don't know if this question makes any sense, but you say U is just a measurement from a source of randomness. Like, okay, so you input. I mean, if you have the sample space like rain, cloudy, and clear, and yeah, you define U in a certain way. Or I guess is a random value just from the sample space to R. So okay, I think I just need to do. There's some questions here. Is there a jumping? I mean, this question was at the end of the book, so probably it's not a good idea to start there. Ay. I'll start with easy questions, with the distributions. I'll not get ahead of myself. Ay. So we had the discrete distributions, which apparently is a collection. What was the definition? Okay. This is the collection of probabilities for all subset B of the real numbers. Think of a regular 6-die toss and the question you can ask about it. Like what would a random variable be in that case? Like I honestly I don't really get it. Like what the point is, or like how to apply it really. Maybe I haven't really done any problems with random variables, so probably I should focus on that. If I program a random variable and think about the meaning of px in A, so what would A be in this case? Is it just a set or right, it would be just like any real set, and that would be the distribution from the definition. So I mean, okay, well, let's define X, appropriate random variable. I think it's good for intuition. Okay, so well, a random variable is from, in this case it would be 1, 2, 3, 4, 5, 6, and then to R. And I mean, for any input t, I would just define it as like 1/6. Like, this is the probability of, I don't really like, how should I define it? Just as t, or what is the meaning of probability of? Like I mean, this is, for example, 1, 2, then it would be all x's that would input to that. X is not a probability, it is the real number associated with the result of an experiment. Okay, but okay. T is good. Okay, so alright, so I mean, I guess if we have 1, 2 here, I remember I did this before actually, but the different t's such that x is a subset of this would I mean, would be either 1 or 2. I mean, in this case it's maybe not the, I mean, I guess you could write it down as this or this as die, different die. How is 4? Okay, so 4 is this, 5 is this, and 6 is this. And the probability of getting that would be would all be 1/6. But what is the distribution? Is the distribution like a function that, given any subset B, actually I'm not really sure. Probability measure in this case, it would just be and probability measure maps it would just be 1/6. University level? I guess so. Like for element t in the sample space, it would just be 1/6. Maybe if I have another book, this will be better. How is your mind not tired yet? I'm getting there, I'm getting there. I'll search Wikipedia. Random or distribution for a probability measure is over the sigma algebra, so it can measure more than just a single t. I mean, yeah, right. We define the sigma algebra to help us define the probability. So let me close this all these stuff. Yeah, sorry. It's the cardinality of t given t is in like the power set of the sample space. And this would be a sigma algebra. I mean, this is maybe the strongest sigma algebra. I guess we get to decide our sigma algebra, right? X is just a mapping from the result of the experiment to the reals, and as such every query or whatever on X is just a query on the result. Right. So the input we input the, like if we have an experiment where we roll die, we would input for example the like if we get a 1 and a 2 and a 1 and a 2, and is it just a way of like of somehow like processing the data or something? I don't even know. Or making it mathematical. Think you're watching a horse race and the random variable X is the number of horses who won. Okay. Right. Yeah, I don't know. This is weird. I think I'll just maybe do some problems and maybe it will make sense. The entire idea of this. Not the number of horses, the number of the horse. Oh. I'll ask ChatGPT, what is the idea of a random variable? Oh, definition. Yeah, I appreciate you trying to explain this to me, who is NN18. I'll see what ChatGPT has to say, because I don't know. It seems like it's still not really clicking. The idea. Like I feel like I have no intuition to what I'm actually doing with this. And now as the definitions stack on, it's just gets hard to track exactly what's going on. Let's see if I can get another perspective. General way to assign a number to each possible outcome. Yeah. And the outcome would be the outcome of an experiment. Okay. We started with a probability space. We have our sample space. We have our sigma algebra. We have our probability measure. Set of all possible outcomes. Messy probabilities of those outcomes. And random variable is a function when the experiment produces a particular outcome. The randomness of x comes from not knowing which omega will occur. Didn't click to me either at first. Yeah. Well, that's nice to hear. Even ChatGPT is taking time to answer this. Indeed. Okay, let's see. The randomness occurs from not knowing which omega will occur. Once outcomes are turned into numbers, we can use calculus and algebra distribution expectation variance. The formal condition, measurable, just guarantees events like x are legitimate events whose probabilities we can talk about. A die. So we have a random variable, indicator, transformation, all are functions from outcomes to numbers. Each gives a different numeric summary of the underlying outcome. Number of heads. First tosses heads. Here x2 is equal to those sets are events whose probabilities you compute with p. I mean, but how do you decide the random variable function? I guess omega, I guess it kind of makes sense. Like in each of these cases, we're performing a so-called random experiment. Like either we're flipping a coin, or we're rolling a dice, or we're maybe looking at the weather, or maybe this is too short writing t x of t is 2 based on your use case. Yeah, yeah, that makes sense. So like when x is equal to 2, what is t? But I guess we could have events. I don't know. I guess this is a model that like I remember like in the book it says like probability theory is a way of like reconciling with our ignorance or like a way of somehow formalizing ignorance in a way. But I guess like usually in maths you assume some things that are true, but in this case you don't really know. It's not like deterministic in any way, which I just find kind of unintuitive. suppose that you just want to know whether horse 7 won the race, then you would define x is equal to 1 if 7 won, otherwise 0. It is completely deterministic. The only random thing is the result you actually observe. Yeah, exactly. Yeah, yeah, that's what I mean. But what I'm thinking is, can't you, like, if you're observing something that like has an equation, or like, or maybe it doesn't make sense. Like if you're observing a light switch, like, or a light bulb. Wait. Let me gather my thoughts. Hello, Rosie, by the way. Right, so I like your example. Yeah, if we just want to know if horse 7 won, we define the random variable in such a way that it will help us. Okay. Different functions give different distribution. X is uniform, R is not uniform. Was our random variables are defined with descriptions, like let X be the number of times a student came into class today? Some of the time, yeah. Alright, so in this case, X is a uniform random variable. So then we know that if the probability of X being between Like what I'm thinking here is, why can't B be like 100 and this be 1? Then wouldn't the output be crazy? Or maybe not. Oh, okay, so wait. B is any subset of oh, is there a way to graph this? Right, if we do example 2.2, 3, so the probability is this. And we have that, I mean, rain, snow, what is it? Cloud, clear? And this would be the probability. How much more time we're gonna stream? I mean, we've done around 6 hours, so I guess 4 hours more. Or better probability y less than x. Like when I'm thinking of a distribution, I guess this is also a little bit of my confusion. I'm thinking like normal distribution, and we have like the area below is always like 1, you know? Like in this case, can we draw a similar kind of diagram? Because I also think like I saw my lecturer talking about like discrete distributions, continuous distributions. Like, is this like a flat type of graph that's like constant? So I guess in this case, the random variable is such that we only care about when it actually snows. And, right. So I guess I wouldn't draw a diagram where snow and clear are different. Or rather, rain and clear. Yeah. I don't really know how to draw it. You can draw the cumulative distribution function though. You can't draw a probability density function for a discrete random variable, unfortunately. You can just draw the CDF. Oh, okay. Well, I mean the probability density function is, I forgot exactly how they wrote it though. Like little x. This is the probability of x. Like this, no? Let's just write probability density function. But these are for continuous. Or this would be, wait, okay, well, probability mass is a function that gives you probability that a discrete random variable is exactly to a specific value. Exactly. It assigns probabilities to each possible value of the random variable, ensuring that all probabilities are non-negative and sum to 1. Right, so you would be able to draw the probability mass function, huh? Right, so x in this case would be like this type of picture. So in this case, this would be 5 and this would be 7. And 5 basically encodes snow and clear. Or maybe I forgot. Maybe it was rain. I don't remember. And this would be 8.5. And this would be like 0.15. Yeah, here we go. Px. Yeah, so this is okay. Maybe I'm. Yeah, this is the usual notation. Px, and we have the x. This probability measure. there is a probability mass function which is like a histogram on the values of x. Yeah. Okay. Thanks NN18 for bearing with me, like with my I don't know, with this stuff. The distribution of random variable x is the collection of probabilities. Let me just ensure understanding via ChatGPT. The decision of how to define the random variable stems from what you want to get from certain observer. Good practice for me also. I TA the probability course in my uni. Oh, nice. Oh, perfect. We have a TA in the chat. Nice. Yeah, your examples were very good. Let's see. A random variable is a numerical view of an outcome. Like, there isn't a right way of choosing a random variable. I mean, there are many ways of doing it, but okay. Blah 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 blah. Okay. Let's see here. Hello, it's Shiny 575. Most students don't fill out the teaching surveys. Oh, okay. I mean, yeah. I guess I know, like my analysis teacher literally spammed in the Canvas page to fill out surveys, and yeah. Okay. Ew. I think this was a pro. Okay, let's do this one because I haven't done that one before. Or maybe I'll start with the easy ones. Okay, I'll start here. What are you currently studying? Am I using Linux? I am. I'm doing some probability theory. Trying to get the basics, to be honest. So this would be, this is the probability density function. I mean, is that really an appropriate name? Does it really measure density of anything? Or no, it's probability mass, sorry. Think of probability as mass helps to avoid mistakes since the physical mass is conserved as the total probability for all hypothetical outcomes x. Okay, I guess that makes sense. I mean, it's a valid comparison. It does motivate the name, I guess. Wait, before I move on, I want to look at this, like the definitions. Yeah. Um, Alright. I'm becoming more and more convinced. Things are looking okay for me. You know, the students I have on one variable, when they saw the definition of a limit, they asked me if I was as like confused as they are right now, and I said yes, and then they and then they were like shocked, like, oh yeah, so there is a point where I will actually understand this. And I feel the same way here, like, to be honest. I just need to have faith that there will be a day where I actually do understand this. Okay. Yeah, so right. So I guess it can be head. Cool. So the probability that we have, yeah, so right, so x is defined to be I'm not sure how to write this though. Or rather, or yeah, the range. And I have 2 notebooks full of nonsensical trying to understand the basics. Yeah. What are you currently... Oh, yeah. I already read that. Yeah, so when it's 0, we have that the probability will be... Right, so let's define the probability function. to be if A is an event, then it would be or wait. Like also with the like the sigma algebra, how do we choose that? Like when defining our probability. I haven't really looked into it that much, but seems like an interesting like for a probability space. We have the sample space. And then we have the probability. You can always just use the power set, but for continuous it's trickier and probably out of the scope. Okay. Yeah. I'm taking my time, man. Okay. Suppose we flew 3 fair coins, so let X be the number of heads showing. Let's see here. So we have x. For x is equal to 1 or 0. Alright, I'll skip this one. I think I already did this one, I remember. Let omega be this. Okay, I want to do 2.2.8. The bowl contains 10 chips, each uniquely numbered 0 to 9. The chips are thoroughly mixed. Okay. One is drawn, and the number on it, x1, is noted. This chip is then replaced in the bowl. The second chip is drawn and the number on it is x2. Compute. Okay. For continuous random variable, you usually choose this sample space to be R, and then choose the sigma algebra to be the Borel sigma algebra on R. Right. Yeah, okay. I remember this is something done when defining the distribution though. That yeah, I don't quite remember. Anywho. Okay, so we have this right. I mean, for every real R, I mean, this would rather be for every integer, or rather for every natural number. Yeah. And this could be chip is then replacing the ball, second chip is drawn and the number on it x2 is noted. Right. mean, okay, so our sample space is the chip, like chip 1. I mean, the probability function would be I'm stealing it. Yeah. I mean, also I'm wondering, like, what is the basis of choosing this? Is this just a good model for this? Like, I don't really know, like, I don't really have a logic for choosing a certain probability. I'll ask this to maybe ChatGPT. Second ball is drawn and number of x2. Probability always given. Here the quote-unquote thoroughly mixed gives us this fact. Yeah, and I guess when we say like a fair die or a fair coin, we just have this probability model then, or measure. Well, ay. X capital. The range is from 0 up to up to 99, I guess. This is not great. Done with all the exams now. Got 72 out of 75 in mathematics. Good job, Raheem. Awesome to see. Yeah, that's an awesome score. You should be proud of yourself. Definitely. Okay, well, I think I'm just gonna take a little break. Or maybe I'll just ask a hint from ChatGPT before I go. See if we can solve it. Have we reached our goal? Okay, we have 1 hour to get 5 super chats. Is this possible? Probably not. I'll do 250 push-ups if we reach the goal. I'm not sure. Yeah. All right. All right. W is uniform on 0 to 99. So they're independent. Okay, this is definitely not a hint. This is a word solution. Probability of getting this is the same as probability of getting that and the probability of getting that. Yeah, so we can view them as a random variable themselves. x1, x2. Since they dependent and uniform on 0 to 9. Took a break from studying and came to YouTube to post mine. Wait, what do you mean to post mine? Well, yeah. Well, enjoy your break, Blue. Hello, Joel. Welcome, welcome. What's my major? I'm doing maths, majoring in maths. Hence the title of the stream. Do I mentor submissions on work assignments? I have one assignment where I did a lab on stats, and then I have like a there's an assignment I think for linear analysis as well. You need to I don't really remember exactly what it's gonna be about, but it will come in the future. But yeah, that's probably it. I probably just have to, and yeah, there are like 4 labs in total in the stats course. So. Okay, let's see if I understand this. Probability of W. I'm just gonna copy what ChatGPT did, but I mean, I guess we can define it as like that. Yeah, this I don't really get it that much. Maybe I should take a break or something. And then, yeah, I don't know. By the way, what classes do I have tomorrow? I have ODE. Okay, that's nice. So I can focus on linear analysis tomorrow. I didn't need to do it today. Or Fourier analysis, which I wrote in the agenda. I think that's a good idea because I just want to focus on this stats stuff. Oh, I just remembered that I was supposed to do something I forgot to do. I should invite my gosh. I said I was gonna invite my friend to the oh, bruh. Yeah, we have like a lab which I mentioned in stats, and I forgot to invite my friend, or I did invite him, but then he sent me the wrong email. But whatever, I need to do that now. Seems like I can't log in. Biscuits. Alright, let's see if I can do it on my phone actually. Photography? What is this? Okay. Yes, overleaf. Oh man. Let's do that. Okay. All right. What am I studying? I'm doing stats right now. Okay, well, I think I'm gonna take a break. We're almost reached the 7-hour mark. I'm gonna grab something to eat. I'll be back in like 30 minutes. Yeah. So I'll just call this dinner break, and then yeah, I'll be back in like 30 minutes. So yeah. All right. Cool. I'm not sure how long it was gone. Probably it was around 30 minutes. All right, let's start again. I miss drowning in math. What? Oh yeah, okay. Let's do the last, what do I have, 2.5 hours? Alright, let me get some water first. Nice. Honestly, I recommend Minecraft music when studying. Not gonna lie, it's actually really good. Okay. Can't enter study rooms from Discord. I think you need to verify yourself first. If you haven't done that, yeah, do that. You need to like take a picture of yourself with like the server name, I think. Yeah. Don't understand. I think there is information on the Discord server. I'm not really, I don't really know as well. But I think you need to do that. You can ask the admin, what I forgot his name. What's the admin's name? Let me just find it. But everything should be on Discord, so you can ask Lotus Princess or one of the admins if you can't find it. Signature is drawn. Man, this is. So basically we have that we can't have 999, we can't have 8877, so on, 00. I guess this set is taken away from the set 1 to 99. Hello, it's Shen. Am I studying? Are you studying? I have a question I will ask you later. Well, you can ask the question now if you want to. Or whenever you like. Let me think. Yeah, so this would be one that we're I mean, wouldn't the probability be of omega of, I'll just call x, p of omega is equal to x, which is p of x1 when it's x1 I guess, and x2, what is x2, where x1 is not equal to each other. I'm not sure if this helps me to BH. Which lineage distributor do you use? I use Arch, and you can call me Cheyenne. Alright, that helps. Well, I use Arch as well. But yeah. I think it's just 1 over 10 times 1 over 9. That would be my answer at least. Right, yeah, it's discrete if they sum to 0 for all x in R. Right. Yeah, and this is probability function or probability mass function? It's a way of it's a random variable. In this case, clearly C is discrete with probability function PC satisfying PC of C is is 1, and PC of x is 0 for all x that are not C. Point mass of point distribution to generate distribution. Algebra or geometry? I'm neither. I'm doing stats. Consider flipping a coin. Yes, it's the Bernoulli. Anytime we have a response variable that takes only two possible values, and we label one of these outcomes as 1 and the other as 0. For example, 1 could correspond to success, 0 to failure for some quality test applied to an item produced in a manufacturing process. So this would be our random variable. Anytime we have a response variable that takes only two possible values. Is this a random variable or response variable? And we label one of these outcomes as well. 1 could correspond to success and 0 to failure. In this case, theta is the proportion of manufactured items that will pass the test. Right, so okay, let me clarify with AI. So different kinds of distributions occur when different random variables are different depending on how you define your random variable. This can give Bernoulli distribution. I guess that makes sense. Since the distribution is the probability corresponding to your random variable, and I don't know if is the distribution like independent of the probability measure or metric or whatever. Is the probability law induced in R by the way you map outcomes to numbers, your random variables, and any parameters of the experiment. Right. same experiment, different functions imply different distributions. Different experiments can yield the same distribution if the included law on R matches. That's the whole random variable as a function idea in action. The total of number of heads showing by 1.4.2, we see that x total number of heads. All right, so we're counting when flipping n coins. Probability that it's 11 p.m. Have to wake up early. Good luck with studies. All right. Well, what is the question? Have a question? I'll ask you later. All right. Well, you can ask it tomorrow, I guess. But yeah, good night. Well, wish you a good night's sleep. Right, so in x, if we have a coin, n times, coin, number of ways to pick x from n, and then the probability did you derive this? A random variable is said to have Bernoulli. Alright. Write this as the Bernoulli distribution corresponds to a special case of. Yeah, right. So when it's 1. Figure 2.3.1 contains the plot of several binomial probability functions. Number of heads, independent flips, event, axis, probability of one particular sequence of x heads and I mean, I guess since they're independent, okay, that makes sense. What am I studying for? This is just for the courses I'm doing. I'm doing a bachelor's in maths right now, so yeah. This doesn't really make that much sense to me. Or I guess I don't really know why my argument doesn't make sense. Let's see. Or I guess, yeah. also any such involve any independent performances or in the system. For each performance, we're recording whether a particular event has occurred, called success, or if it has not, called failure. If we donate the event in question by A, input whether the number of successes in the end performance is distributed binomial. We could be testing a light bulb produced by a manufacturer. Right, so given n light bulbs, how many work? That could be a random variable. The number of working light bulbs. And theta would be is the probability that a light bulb works when tested. Then the number of bulbs that work in a batch of n distributed is distributed binomially. And if a baseball player has probability theta of getting a hit when at bat, then the number of hits obtained in n bats is distributed binomially. There is another way of expressing the binomial distribution that is sometimes useful. For example, chosen independently, and each has the Bernoulli distribution. Then y will have binomial distribution. Oh. Right, so if you have xn being Bernoulli of theta, given probability theta, then y sum is binomial bin of n theta, so n independent events. Geometric distribution. Consider flipping a coin that has probability theta of coming up heads and probability yn minus theta of coming up tails. Where we again have that 0 to 1. Let x be the number of tails that appear before the first head. For k greater than or equal to 0, xk, if and only if the k shows k tails followed by probability of this is equal to okay, so x is geometric. Given random variable So the probability mass function of x at x is equal to apparently 1 minus theta k. I mean, sample space is just heads or tails, and we obviously have probability of any event, which is the indicator function 1 times theta plus indicator, or rather heads tails. Yeah, that seems correct. So I'm guessing we have how many coins we're flipping and the probability function. Then if we plot the probability density given the random variable, no, given different x's, given 1, 2, 3, 4, 5, 6. Then we have exponential decay. In particular, the probability of getting an infinite number of tails before the first head is equal to, which is 0. So x is never equal to infinity. Hence px of k is equal to, x. So if I want to get but we're flipping, let's see, consider flipping, repeat the flipping a coin, that's probability theta. 2 more hours. Switch to chemistry, enough of physics today. Darin still going strong. I mean, definitely energy is dipping. Granted, music is helping. But yeah. Were you hearing at the start, Sumaya? Yeah, you were. So you've been doing physics for 8 hours. Respect. Yeah. I mean, switching subjects certainly refreshes the mind. Actually, I think I'm getting a hand of this. This whole stats thing. Which is interesting. I was thinking about like doing these streams is kind of interesting since I can think like 10 years in the future when I'm hopefully like very comfortable with math. It would be nice looking back at my my struggles with more basic math during my second year. I wish I did like these streams during my first year. That would be kind of interesting seeing. Or even during high school. Oh, that would be super interesting. I mean, I guess I can look at my study with me streams, but I don't really get my reflection. But yeah. Is your agenda for today complete? No, actually not even close to being complete. I will not complete my agenda. Like the tasks I have. Oh, by the way, I forgot to change. Like, I'm not doing ODE anymore. I mean, regarding ODE, I actually finished that, so I'm happy about that. But statistics, I wanted to begin with the questions, but I couldn't understand anything, so I just went back to the previous chapter, which is fine. But yeah, we'll try to do as much as possible. So. What time did you start the stream? I started the stream 8 hours and 20 minutes ago. Though granted on Restream it says I started 7 hours and 44 minutes ago. But yeah, it's 8 hours and 20 minutes. I don't know what... On YouTube it also says. So. I'm not even sure the time. Yeah, it's close to 8. So basically, I think I kind of get what a random variable is. It's just a way of... like sort of like it's the function that decides what you want to look at in your observation, basically. Like given the same sample space or sample set, we can have two different random variables, i.e. two different ways of looking at flipping a coin. which will give different probability density, like probability mass functions. Thankful you started the stream. I feel motivated. Looking back these days will sure be nice. I also want to record myself studying. It would be interesting. Yeah, I highly recommend it, Sumail. Seems like I have the drive. I mean, so I would highly recommend it. So I mean, for me, when I started the channel, the first 70 days, I couldn't dare to do any live streaming. It was way too scary. Since I was afraid to mess up, if I spoke something that was not correct in whatever way, being grammatically or when it came to actually explaining stuff. But eventually that fear kind of disappeared. But yeah. So you can slowly transition into it, doing short streams and stuff. In particular, the probability of getting an infinite number, blah blah, has the random value x is said to be a geometric right. So there isn't really a bound for how many times we flip a coin. It's just the infinite, which is interesting. Figures 2.3 contains the plot of several geometric geometric of 1/2. Wait, what does that mean even? Geometric of 1/5. Could you answer my question? Do you have ChatGPT Premium? If so, was it worth it? Sorry, yeah, I do have ChatGPT worth it. I do have ChatGPT Premium, and I do think it's worth it. I mean, I know I have a friend who has 3 Google accounts, and since I think every month you get a couple of you can use ChatGPT 5 times or something each month. He basically switches accounts, which is kind of tedious, but I mean, I use it a lot, every day, so I think it's worth it. But it is very, very expensive. Not gonna lie. How much is YouTube Premium or ChatGPT Premium? I think it's 220 euros or something. So it's not cheap, or even more than 20 euros. I mean, I don't really get how this is true. This is not really a rigorous book, I think. The geometric distribution effort was whenever we are counting number of failures until we first success for independent of random system where the occurrence of some event is considered a success. The number of light bulbs tested that would work until the first light bulb does not. A working light bulb is considered a failure for the test. For example, the number of light bulbs tested that work until the first light bulb that does not. Oh, okay, yeah. So then you would have probability that it does work, probability that it doesn't, and then you can model it. And the number of at-bats without a hit until the first hit from the baseball player. We note that some books instead define the geometric distribution to be the number of coin flips up to and including the first head, which is simply equal to 1 plus the random variable defined here. Wait. Is like k followed by a head. Yeah. We get Perplexity AI for free for a year, which I use. It is free in our country. ChatGPT is 19 quid a month. It's something like that. When I saw quid, I was like, oh, British accent, let's go. What country are you from? I have been single whole life. By the way, I do read Twitch. I do read it. India? Oh, okay. I've never heard of Perplexity AI. Simply equal to 1 plus the random variable defined here. Right, so so random variable is the number of heads coin shows exactly k tails followed by a head. Generalizing the previous example, consider again repeatedly flipping a coin that has probability theta coming out of heads and probability 1 minus theta of coming out of tails. Let R be a positive integer. Maybe the number of tails that appear before. I'm not sure if I didn't understand this. So what? Number of tails after. No, this is not it. So it will be k tails the number of tails that appear before. Yeah, exactly. Not after. I wrote after. Tails before first head. So you would have, if x is equal to 3, doing probability until end of stream. Yeah, I'm gonna do it. I'm not really that I need to spend time on it basically. Perplexity has its own LLM tied up with ChatGPT Gemini. You can use them for free for a year. Oh, okay. Cool. Wait, I don't understand this. Where am I from? I'm from Sweden. Like the most southern part of Sweden, which is called Skåne, near Denmark. But no Swede wants to admit that they're close to Denmark. But no, that's like a Swedish inside joke. Yeah, I don't really get that. I mean, wouldn't the only way to get x is 3 isn't it only one way? Or maybe I'm totally misunderstanding. When x is 3, like is the pre-image, if we say this is x, isn't x just equal to tails, 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 heads, heads, dot dot dot? Or rather, wouldn't it be infinity? Like, because we're flipping infinitely many coins, or arbitrarily large amount of coins. We're trying to figure out what the probability space is for the regular distribution. Well, I mean, specifically for the geometric distribution, like, I don't really understand this. Wouldn't it be infinity? Like here we'd have heads, heads, and then we could have tails, 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 heads, tails, dot dot dot. So I don't know. I guess I'm trying to understand. I guess, yeah, how probability measure is exactly equal to this. Like if this is the probability that we have heads, and then this is the probability that we have wait a minute. These are not disjoint events, or right? So we would get right. So the probability of tails is that. So this is the probability of getting tails, tails, tails. If x is 3, for example. The preimage is all infinite sequences of ht starting with hh. Yeah. How many coins are you tossing? We're tossing arbitrarily many coins. Or rather, we're repeatedly flipping a coin as many times as we want. Okay. how do we get the probability function or math function? Which is which is p of x is equal to theta times 1 minus theta to the power of x, given theta is the probability of getting heads. I mean, we don't need to say heads, but and 1 minus theta. The sample space is all infinite. Yeah. Try using Gemini or Perplexity AI with research mode. Let's see here. Perplexity AI. Damn. Academic. Natural science. Oh, this is like a newspaper summary of the latest trends. Gemini is free for uni students? I didn't know that. Never used Gemini. By independence. I mean, I guess I understand independence, but version A, x is equal to number of failures before first success, means x trials or failures, x plus 1 is success. And by independence we have by independence. how many independent tosses of a coin until we get H. Yeah, independence just allows up to multiply the probabilities when considering the intersection of events. So independence just means they're disjoint, two disjoint events. Or I don't know. P of A and P of B. Do not depend on each other. But I don't know if this is. I mean, this is where my head is going. We have this. So we have all x, which is equal to, for example, 3, and then it would be probability of the set tails, 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 and then we get head, and then we get an infinite sequence of whatever the f, and then we get this like infinitely many times, right? Maybe I'm modeling this wrong. Maybe I'm modeling this wrong. An event, let's see here. Okay, so an event here would rather look like T and T and T and H. Or wait, what am I doing? Wait. Let me reconsider. Yeah, what is those? What is the sample space, by the way? Like it would be, yeah, I mean, yeah, I think this is correct what I did. It would be tails, 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 heads, and then any other sequence here, and then we have infinitely many of those. But how are they independent? Okay. Isn't probability of capital X in X equal X equal to probability of X, no, this tails, 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 head, dot, 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 given n is equal, given x geom of 3. Wait, does that make sense? Yeah. There are infinite appropriate sample spaces. You can also define as all finite sequences ending with H. Yeah, I think, that's, yeah. And all other entries are T, if it is more intuitive. But I don't see how, like, if you do that, then it makes sense for me. When you have a finite sequence, and I think this is what ChatGPT is doing here. He's just considering this x times and then ending with s, and then he doesn't care about anything else. Vad är ens problem med? Well, I mean, I guess you can speak Swedish. I guess it's the problem, Marcus, is just understanding the geometric distribution. Blah 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 blah. Yeah, two equivalent choices. An infinite sequence. An outcome is with independent trials. Define x, the number of failures after first success. Then we don't care about the rest in our definition, as the rest doesn't matter when you reach H. Oh, maybe that's true. Yeah, that would. Let me think. But this is not really, I don't know, it doesn't really make sense to me still. let's see here. Ah, I get what this means now, actually. Okay. Okay, never. Yeah, true. Okay. Sigma algebra Pn, no, also are measurable. Wait, let me see here. X plus 1. Sample space is the space of possible outcomes, and our experiment is tossing coins infinitely many times, which is better described as a vector ht of n. I mean, where n is like the natural numbers, or what is n here? I mean, it would be an infinitely long vector, I guess, yeah. But I still believe, I mean, it feels like the like the codomain would be, or the yeah, or the, not the codomain, the what is that? Yeah, the preimage would be like an infinitely large set, and like I've written sloppily here, and I'm not really sure how to compute this now. The one with which the number of times to first success. Yeah, exactly, Marcus. So if so, all vectors are not valid. N is, yeah, natural numbers of n. They are, you just need to look only on vectors who begin with only t and then h and then whatever else. cylinder set. Maybe I should just move on. Okay, maybe I'll just move on here. We have a debate. I'm just gonna move on, and then I'll I don't know. I guess yeah. It's not totally clear why this is the case. Seems like there would be an infinitely amount of either heads or tails after the first x plus 1 terms, or like number or like elements of the vector, but yeah. But I guess they're invalid in a way. A cylinder set? I've never heard of a cylinder set. Is that really a thing? Okay, negative binomial distribution. Generalizing the previous example, consider again that repeatedly flipping a coin that has probability theta of coming up heads and probability -1 to come up tails. Let R be the positive integer and let Y be the number of tails that appear before Alright, I'll be right back. I'll head to the bathroom, take a bit of a breather. I guess we have 1 hour left, so yeah. Let's actually make the last hour really productive, I feel like. Okay. Alrighty. The intuition is literally define whatever space you want and put on a measure that matches the probability mass function. Alright. Yeah, I'm not even gonna try to understand the debate going on. I mean, yeah. Let's move on. Generalized in previous example, consider number of tails that appear before the r's head. Generally, the coin shows exactly r minus 1 heads. On the first r minus 1 plus k flips. And then shows the head. Okay. So you got this for k plus 1. The random value y is said to have the negative binomial. We write this y. Of course, the special case r1 corresponds to geometric distribution. So in terms of our notation, we have that negative binomial or theta distribution applies whenever we are counting the number of failures until rth successes for independent performances of a random system. For a random system where the occurrence of some event is considered a success. The number of light bulbs tested that work until the third bulb that does not, and the some number of, I don't know what AT bats are, without a hit until the fifth for the baseball that shows. Yeah, so it's basically like tails, 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 heads, heads, and this is R, and this is K. It's holiday in my country, so we're allowed to waste time right now. So it's algebra alg top vid, and assuming it's at least master student. Wait, what do you mean alg top? Is it? Do you mean the algebraic topology? I think I had like a thumbnail. Yeah. Well, I guess that was, I don't know. Well, this is a course that I'll be taking, yeah, in the coming semester. But actually, now that I before or after making the video, I'm not sure if I'll take that course. I feel like I'm probably not at that level. Well, I try to understand this. Wait a minute. On the first r minus 1 plus k flips. And then shows ahead on the rkth flip. The probability of this is equal to alt top is hard. A tip might be just to try to write down an expression for the theme yourself. That helped me a lot. If you get the same PMF, you know you have understood. Yeah, I guess so, but in my head it doesn't seem to be working out that well. Wait, so r here is plus k. So in this case it would be 4, so it needs to be exactly. And then shows ahead on the r plus k flip. Man, I'm way too tired for this. Well, it's certainly not this. Wait, let me see if there's a better explanation for this. Think of the first performing all x tosses, then all possible arrangement of the tosses. I mean, well, if R is 1, how should I do it on the first? I don't get, like, if R is 1, how is this the geometric distribution? So if it shows 0 heads on the first. Oh, okay, yeah, my bad. Yeah, my bad. Yeah, okay, now it makes sense. Yeah, sorry. So it would be r minus 1 plus k, choose r minus 1 ways of getting r minus 1 heads among r minus 1 plus k flips, and the number of heads, like the probability of heads is theta, and we get r minus 1 theta, and then we have and then it shows a head on the r plus kth flip. And we have a theta there. For example, if r is 2, we would have man. And for example, if we have five flips, we would have that on the first right, so we'd be ahead in the end, and then some kind of for example, tail, head, tail, tail, tail. We get through tail there. Yeah, and yeah, of course. Okay. So the tails are of k amount, and the last one is all right. Probability PhD hunting. Oh, okay. I'm guessing you're Swedish then, Marcus. I mean, Sweden is a good place to get a PhD, or like to do a PhD. Pretty sure, at least. Is this geometric distribution? Yeah, it's I mean, this is specifically a negative binomial, but yeah. Studied Chalmers? Nice. Man, this Minecraft music is actually great. Oh man, that only took 20 minutes. Okay, let's move on. Poisson distribution. We say that a random value of y has a Poisson and right blah 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 if y is equal to this, and then we have a lambda y given some lambda, I guess, factorial e lambda. We note that since it is indeed true, as it must be, that figure 2.3 contains the plots of several Poisson distribution functions. Seems to live in Sweden. Yeah, I'm from Lund. I'm in my second year at Lund University, doing a bachelor's here in maths. Poisson distribution, one of my faves. So simple and yet so powerful. All right. Like, what is your interest, Marcus? Are you like a stats? Like, what did you write your I'm guessing you've done your master's, right? Or if you're looking for a PhD, like in what area are you hoping to do your PhD on? Hello Lorik. Darin svensk, jag kommer ihåg honom från TikTok. Noise, Lorik. Suddenly we're getting a bunch of Swedes in the chat, which is kind of interesting. Masterboard on K-theory, churned classes, and vector bundles. Oh, okay. I don't know what any of that means. But is it more like analysis, algebra, or is it statistics? I'm a lost student. I seem pretty lost. Me too, Lorik, me too. We motivate the Poisson distribution that follows. Suppose x is binomial. X has the binomial distribution. Then for x between 0 and n, we have this. If we set theta to be lambda divided by n for some lambda, then this becomes okay, I guess. Written like this. Let us now consider what happens if we let n go to infinity while keeping x fixed at some non-negative integer. All right. Topology manifolds. Nice. Yeah, I'm really excited for topology. I'll be doing my the first topology course next semester. Very excited about that. The most intuitive distribution, I give you the example my lecturer gave me when I first learned it. Wait, let me first read this. I'll read it. While keeping x fixed in that case. I guess that's the derivation, eh? But we're assuming that the probability can be written as lambda divided by n for some lambda. So we're assuming a specific probability function, no? How was your high school journey? Can you summarize it in brief? We're talking about me? Were you always STEM focused? I assume he's not from Sweden, but he's now studying here. No, I'm Swedish, Marcus. Like, I was born and raised here, or I guess I was born in Finland, but when I moved here when I was like 5. But yeah, I was during high school. I guess I have documented my entire journey here on this YouTube channel, but I was mostly an art student, right? I was obsessed with art until starting my 3rd year, and then I went into mathematics, having not done any mathematics before. So yeah, I'm very new to mathematics. I only have like 2.5 years of like experience. So yeah. Not assuming anything, just do the change of variables, set theta to lambda n. But like I guess n is fixed, right? Yeah, I guess that's true. Yeah, n is fixed and we can pick some lambda. So I guess that's true. It's just change of variables. True. Intuitively, we can phrase this result as follows. If we flip a very large number of coins n, and each coin has a very small probability of coming up heads, then the probability that the total number of heads will be x is approximately given by has a very small probability of coming up heads. Okay. Where we are approximating the binomial 100, 1, 10 distribution by the Poisson distribution where lambda is 10. Scroll down to your past streams. You really did grind in your last year of high school? Yeah. I did 10 hours studying for 206 days. Indeed. Basically, the PMF of binomial is Poisson in limit when n go to infinity. Yeah, I guess so, yeah. Yeah, I guess we just do change variables to calculate the limit, I guess. Yeah. And n is the number of, yeah, it's the number of times we flip it. Flip the coin. And for each coin has a very small probability. Well, I mean, we're taking the n as it goes to infinity. I mean, so we are assuming something about the probability, no? That it depends on n. That as like, yeah, we are assuming that the probability is very, very small. So it cannot be an arbitrary probability, right? So the probability needs to depend on be proportional to the inverse of n. Or that's at least what I'm feeling. Mean of variance of bin. The mean is n times p, but here p is lambda n. That's why it's lambda divided by n. You fix n, you write down, you get some expression, you take the limit as n goes to infinity. Imagine there's a lump of uranium 238 in front of you, and you're measuring how many radioactive decays happen during some time interval t. Then this amount is distributed like a Poisson. Oh yeah, actually, I think my lecturer gave the same example, but I didn't really understand it then. Yeah. Because it's a very, very rare event that a radioactive decay happens. The Poisson distribution is a good model for counting random occurrences of event when there are many possible occurrences, but each occurrence has very small probability. Examples include number of house fires in a city on a given day, the number of radioactive events recorded by a Geiger counter, the number of phone calls arrived at a switchboard, the number of hits on a popular worldwide web page on a given day. Partitioning a time interval t into n equal parts, and in each time interval you perform a coin toss with a coin and you measure how many coin toss succeed. Okay. I'm taking the limit. You're basically measuring how many times a very unlikely event happened. You know, there is on average lambda events in the interval t. Should be the same thing too. The Bernoulli on lambda divided by n. Okay, I'm not gonna spend too much time on this. Jesus. I mean, it's good to spend time on it, but yeah. Yeah, thanks for the explanations, Marcus and anything. Suppose that an urn contains m white balls and n minus m black balls. Suppose we draw n minus less than or equal to n balls from the urn, such a fashion that each subset of n wait. Each subset of n has the same probability of being drawn, because there are n subsets. Wait, what? Wait. Right. Its probability is 1 divided by n. One way of accomplishing this is to thoroughly mix the balls in an urn, then draw a first ball accordingly. Each ball has probability 1n, 1 divided by n drawn, then they're replacing the first ball. Oh, okay. Obtain that the probability of any particular set of n balls being drawn is 1 over. This type of sampling is called sampling without replacement. Given that we take sample of n balls, let x denote the number of white balls obtained. Note that we must have that x prisoners, because at most n minus m of balls black, hence where's more x? So X denote the number of white balls obtained. Okay. To avoid this, we know that we hypergeometric NMN distribution. Took me half a semester to understand what a random variable even is. You're doing great, Darin. Thanks for encouragement. Right, so here it would be so 10 10 it would be we draw this many. What is probability that XY balls are obtained? Hypergeometric distribution will apply to any context wherein we are sampling without replacement from a finite set of n elements, and where each element of the set either has a characteristic or does not. For example, if you randomly select people to participate in an opinion poll, so that each set of n individuals in a population of n has the same probability of being selected. All right. I think, do I have any problems from here? Okay, I'm not gonna read this. I'm not gonna read this. It's 2 points. Okay, we're a bit further ahead. Okay, let's do 2.37. of theta. Well, that with theta is px maximized. Alright, so the binomial is 12. Alright, so theta can be, I mean, I guess theta is restricted. Yeah, sorry. Yeah, and the derivative is always positive, so this, or wait, let's see if it's, it should be a max point there. Yeah. 2, 2, 3, 12. So x is Poisson. We have random variable, this. What is probability of the function? Pure. Maybe I'll just do y there. I mean, so n, I guess n is defined to be to be n times or rather lambda is defined to be times theta. No, what was it? Was it the input or no? No, theta was to be n. Yeah, sorry. We're starting in Israel. I didn't know that. And then 18. That's right. Which one? Are you supposed to do convolution here low? Wait, talking about convolution, I'm not sure what you. Wait, let's close this. I'm not really sure. I mean, do you mean the convolution between two like functions? Between x and -7? Oh. Like the Postman functions? Oh, okay. Wait, let me just read this again. My brain is not working. Oh, okay, yeah. Okay. Not really. I completely forgot the formula. Can you just... Last session, right? I mean, I'm not really doing sessions, but these... I mean, the stream is past 10 hours, right? So yeah. I'm not really sure what they want here. Okay, this is the answer, no? I don't know what they want from. I don't know. Like, urn contains 1000 ball. One of these is black, the other 999 are white. Suppose that 100 balls are randomly drawn from the urn with replacement. Use the appropriate Poisson distribution to approximate the probability that 5 black balls are observed. maybe I'll stop here. By the way, when will the stream end? It's 1:10 a.m. here. I have class tomorrow at 8. Oh man. Tomorrow's stream timing. Well, yeah, nice, Sumaya. I remember you were here at the start of the stream. So, yeah, congrats on the 10 hours. Good job, man. Tomorrow, I don't know at all. Wait, I can figure it out. Okay, so I have class at blah, blah, blah. Okay, yeah, so I'll start at around 7 p.m. in my time, which is plus 2 hour UTC. It's Central European time, so feel free to join then. Once you figure out parameters of Poisson here, yeah, exactly. But my brain is like is not really working that well. But anyways, it was nice having you guys here. Thanks for joining, and I really enjoy these math streams, and I really want to do more. So I'll try to do at least a 5-hour stream tomorrow, and yeah. Living with roommates? I am not. I'm living with my my mom currently, but I'll be actually moving out in it is 24th, so I'll be moving out in 21 days to like a corridor room at Kalmar Nation in Lund. So excited about that. All right, good night, guys.